Okay, hello Year 9. Welcome to this lesson on enlargement. We are going to be doing things on graphs yet again, so you will need some squared or graph paper. If you don't have access to any, but do have access to a printer, the description of this video should have some links into some downloadable paper so that you can get your own to print and draw on. Obviously, you're going to need pencil and ruler again, as well as a pen. We're going to be doing a lot of drawing, but also a bit of writing. So you need all of those bits of stationery, please. So let's get started. I'd like you to copy down this diagram and try and do these enlargements from the different centers of origin. If you're not sure, then we will go through part A together. But if you think you're able to do this, then pause the video, give it a go. Okay, so let's go through part A then. So we've got our center of enlargement at 0, 0. So I'm just going to mark that there with our red dot. And the best way to do enlargements from a point are to count the number of squares we have to travel to each corner of the shape, okay? So let's look first at this corner that I've just put a blue dot over. To get from our red dot, our center of enlargement, to that first corner, you can see we go up 1 and right by 1. Well, we're using a scale factor of 3, so instead we're going to have to go up 3 and right 3. So it was up 1, right 1, now it's up 3, right 3. So our blue corner is now going to be here. From our blue corner, we would normally go up by 2, but it's a scale factor of 3, so we go up by 6. Okay, so you can see our 2 purple points, that's where it's now going to be. And our final corner, we would normally go 1 right from our blue point. So instead we go 3 right from our blue point. And now we just need to join them up. And that is our enlargement. Okay, so try and have a go doing the same thing with part B if you haven't already, please. And this is what you should have got. Okay, so when the center was 1, 1, we didn't actually have to move the shape at all from where it started because one of the corners was already on that point of enlargement. So we just needed to upscale everything by 1.5. Question 2 then. We need to enlarge the triangle by a scale factor of 2. So everything, including the triangle itself and the space to the triangle, must become twice as large and using different centers of enlargement. Okay. So the first one, our center of enlargement, is going to be here at 3, 5. So then think about joining each corner up. This first corner, we'd have to go right 1 and down 2. So think what that's going to mean by a scale factor of 2, and then use the reference points along the shape to fill in the rest of it, and do that for the other 3. So pause the video, give that a go. Should take you a few minutes. Okay, let's go through some answers then. So as we said, to our original, we'd normally go right 1 and down 2. So we've gone right 2 and down 4. Then from this corner, we would normally go along 3. So we go along 6. We'd go down 2. So we go down 4. And we connect up that diagonal line. Okay. When it was B with 4, 3, we can see that was the point. So it's in line with this first corner. So we just need to do to go left by 6, down by 4, and connect up the point. Here, when it was the middle, again, we choose a point to start with. So this top right corner, we would go up 1 and right 2. So we go up 2 and right 4, and that'll show the corner of that triangle. And then again, left by 6, down by 4, join up the line, okay? So very similar process. You just have to use the different corners of the shape as your points of reference from your center of enlargement and count all the squares you need to travel by. Question 3 then, need to copy down this diagram, please. And we will go through this together. Okay, you should now have this copied down. So it's asking us to draw points that join corresponding vertices or corresponding corners. So let's see what that looks like. So you can see that top corner of the triangle, point Q and point B are the corresponding ones. So I've drawn a line going through both of them all the way across the diagram. Then I can do P and A in the same manner, and R and C. And you'll see that they all cross at the same point, -5, -2. And our scale factor, hopefully you can see this is 3 times the size of our original. So it's a scale enlargement by scale factor 3 with a center -5, -2. Okay, so if you ever want to find a center of enlargement, this is the way we do it, is by joining up the corresponding vertices and see where the lines cross. And in terms of actually finding the scale factor, however many times bigger this is in any given direction will be the scale factor of enlargement. Okay. Question 5 then, slightly different here. We're enlarging by fractional scale factors, so think what that's going to mean and give it a go, please. Okay, so hopefully you worked out that a scale factor of a half means it's going to be half the size. So that red triangle is what you should have ended up with. And conversely with B, it should be 1/3 of the size. So you should get this red triangle. Okay, so fractional scale factors mean that we're going to make it smaller. Question 7, we're describing an enlargement that maps shape A onto shape P. So remember, you're going to need to find that center of enlargement by joining the vertices, and you're going to have to work out that scale factor. Okay, so you got that it was a scale factor of 1/3 because the shape has been made smaller. And the center of enlargement, hopefully you joined up each of these points and found that it was -5, -2. You may have actually recognized that this was the same as the earlier question. We've just gone from the larger shape to the smaller shape. That's why we've got the same center of enlargement and a scale factor of 1/3 rather than a scale factor of 3, because we're now making it 3 times smaller, not 3 times bigger. And part B, if you can give that a go, please, using the same method. Okay, and hopefully you got this. So again, it was being made 1/3 of the size, and our center of enlargement, when you joined up all the vertices, the point should have crossed at 2, -5 over here. Now we're going to have a look at negative scale factors. Now it's really important to remember, so it's worth noting here what negative scale factors do. A lot of people think that negative scale factors are going to do what fractional scale factors did, which was to make it smaller. That's not the case at all. Remember, when we're doing anything with graphs, a negative is talking about the direction, okay? So when we have a negative scale factor, we make it as many times bigger as the number next to the negative sign is. So if it's -2, it's still going to be twice as big. If it's -1/2, it's going to be half as big, okay? And the negative sign tells us that we're going to change direction, okay? So you can see here, let's follow the red line first. Whereas from our center of enlargement to our original, we would go left by 2, with a scale factor of -2, so it's twice as much, it's 4, but notice we're now going right by 4. Whereas we would go down by 1, we're going up by 2. Whereas we're going left by 4, we're going right by 8. So all of the directions, when we count from the center to one of the corners, we're now going to, as well as enlarging, we're also going to put it in the opposite direction, okay? So up becomes down, left becomes right. So let's give this a go. We're drawing a coordinate grid from -12 to 12, and you're joining up these points to make a triangle, and we're going to enlarge that triangle by a scale factor of -2. So firstly, you should have drawn the axes with your triangle as follows. And let's go through part A together. So we've got our center of enlargement at -1, 0. So I'm just going to put that in there. Okay. And same as we did before, we're going to use the vertices of the triangle as our points of reference. So we're going to take this corner first in our bottom left. And normally to get from our center to our point, we would go up 2 and right 2. So it's going to be twice as big and in the other direction. So up 2 will become down 4 and right 2 will become left 4. And so you should end up with the point being down here. Next, let's take this green point. So to get between the blue and the green point, normally we would go down 1 and right 3. So twice as big and wrong direction, we go up 2 and left 6. And so you'll end up with something like this. Finally, after we've connected those 2 points, we've got one more point in our triangle, this bronzy colored point. Okay, and from the green dot, we normally go up 3. So we're going to go down 6. Now we just need to connect all of our points. You can either connect them as you go or connect them at the very end. It depends really how difficult the shape is. But this is how you do it. So again, as we did with normal enlargements, we count to each of the corners and we enlarge those spaces, but we also do them in opposite directions because it's negative. So up was down, left was right, etc. Okay, so pause the video, have a go at B and C for me, please. And this is what you should have got. Okay, again, remembering to use those different centers of enlargement. If you are stuck at all as to where any of these came from, please send me an email and I will happily explain to you. But this is the end of the lesson. So as I say, any problems at all, email myself and I will be able to answer all of your questions. And I will see you next week. Thank you very much.